Hello everyone, in this video I am presenting my Simulink project titled Fuel Based Vehicle Speed Control System. The main aim of this project is to control the vehicle speed automatically based on the available fuel in the tank so that the vehicle can reach the destination safely with better mileage. The problem statement is, in real life, drivers often drive at high speed without checking the remaining fuel. When the fuel is very low, the mileage decreases, fuel may finish before reaching the destination, the vehicle may stop suddenly on the road. So, the problem is to design the system that calculates the fuel needed for the journey. For example, 1 liter fuel may be enough for 10 kilometers, but not enough for 25 kilometers. So, the system must calculate available fuel is enough to reach the destination. Next, reduce speed when the fuel is low. At this high speed, the engine consumes more fuel, mileage decreases, and fuel finishes faster. At moderate speed, engine works efficiently, mileage improves, vehicle can travel more distance with less fuel. So, when the fuel is low, reducing speed helps save fuel and reach the destination safely. Next, allow normal speed when the fuel is sufficient. If the fuel is sufficient, there is no risk for fuel exhaustion. Now we can move to the model explanation. Fuel level. This is a constant block which represents the fuel available in the vehicle. By changing this value, we can simulate low or high fuel conditions. Next, distance. This is a constant block which represents the distance the vehicle needs to travel. Next, mileage. This is also a constant block which represents a vehicle's mileage, that is, how many kilometers the vehicle can travel per liter of fuel. Next, the fuel required. This is a divide block which is taken from the math operations. This block calculates the fuel required using formula fuel required is equal to distance divided by mileage. This tells how much fuel is needed to reach the destination. Fuel check. This is a relational operator which is taken from the logical and bit operations. This block compares available fuel and required fuel. If available fuel is greater than the required fuel, the output becomes true, otherwise false. Driver speed. This is a constant block which represents the speed requested by the driver. Next, optimal speed. This is a constant block which represents a safe and fuel efficient speed used when fuel is low. Speed switch. Switch block. This block is a decision making block. If fuel is sufficient, driver speed is selected. If fuel is low, optimal speed is selected. The decision logic works like, if fuel is greater than fuel required, the vehicle is allowed to run at driver's desired speed. If fuel is less than or equal to the fuel required, the vehicle speed is reduced to the optimal speed. This logic ensures fuel efficiency, safe driving, guaranteed reach to destination. Speed limiter. The block which limits the speed between the minimum safe speed and maximum safe speed. It prevents overspeeding or very low speed. Speed display. This block shows the final vehicle speed in numeric form. Speed scope. This block shows how the vehicle speed changes over time. Now we can move to the demonstration part. When the fuel is low, the output speed automatically reduced to 45 km per hour. When the fuel level is sufficient, the system allows 70 km speed per hour. This shows that the vehicle speed changes based on the fuel availability. This project improves fuel efficiency, driving safety, decision-based control. This concept can be extended to real vehicle and smart transportation systems. Thank you.